Hello everyone, so today I would like to talk about an important topic in electronics, which is the difference between analog and digital. But before that, let's talk about numbers and quantities. If you look around, you may easily realize that numbers are everywhere. They are used when we deal with quantities, be it the price of chicken nuggets, the mass of a proton, or the distance from the Earth to the Sun. Wherever you live, work, or study at, or whatever it is that you do for a living, quantities are likely to be part of it somehow. From that derives the need to observe, measure, monitor, and arithmetically manipulate them. Therefore, it is required that we be able to represent these quantities efficiently and accurately. Basically, and especially when we are talking about electronics, there are two ways for doing such tasks: analogically and digitally. Here's where things start getting interesting: the difference between analog and digital. In nature, almost every quantity you can think of is analog, such as temperature, sound intensity, voltage, current, speed, time, pressure, and so on. Analog quantities are continuous. That means that there are no gaps in between. When we talk about an analog representation of a certain quantity, we are saying that it is exactly and infinitely proportional to this quantity. For instance, the needle-type speedometer in cars deflects proportionally to the speed of the vehicle, in such a way that the angular position of the needle represents the exact absolute value of the instantaneous velocity of the car and is sensitive to even the slightest change in this value. Another good example is the mercury thermometer, because the column of mercury is continuously proportional to the room temperature. On the other hand, digital quantities are discrete, which means that they have gaps between each step. The number of students in a classroom is an example of a digital quantity, because when you count, you may have 10, 11, 12, 13 students, but you cannot have 10.5 nor 27.76 students in there. That doesn't even make sense. Another example is the score of a basketball game, which may increase by 1, 2, or 3 points, depending on the situation, but you can never score 0.5 point nor 2.42 points. Okay? Digital systems follow this logic. When you look at a digital watch, for example, you can only see the hours, minutes, and in some devices, even seconds. But you know that between these measurements, there are milliseconds, nanoseconds, microseconds, and infinitely smaller measures of time that are not shown on the display. And because of these gaps, the idea of continuity is broken, and therefore you have a digital system. So, with that in mind, a digital system can be defined as a combination of devices that can process and manipulate only a limited number of discrete values, like digital cameras, smartphones, calculators, and computers. You see, computers can only carry out a finite number of arithmetic or logical operations with a good old binary logic, 1 and 0, on and off. Whereas an analog system consists of devices that manipulate physical quantities that are represented in the analog form. Examples of those are the old vinyl players, videocassette recorders or VCRs, and amplifiers. If we were to make an analogy here, we could say that analog systems deal with real numbers, while digital systems deal with integers. Since I wanted to keep this video simple, I'll stop here. See you, bye!